Alright, so here we have another snow day and another video that will hopefully help keep us moving along as we suffer through this weather. The ultimate goal for today is we want to talk about how to multiply and divide real numbers, which is sections 1.4 and 1.5, but we're also going to need a little background information, which is going to come from R.2. So if there's stuff you need a little bit of work on, go back to R.2 and review the material there along with the video to help learn some stuff from there. So the things that are going to be coming from R.2 are going to be the idea of a prime factorization of a number, which is basically taking a number and breaking it down into its prime numbers. Like, for example, 2 is a prime number because the only number that divides 2 is 1 and 2 itself. So some of the prime numbers are 2, 3, 5, 7, 11, 13, and you can keep going and going and going and going. And so the goal is we want to break individual numbers into primes and products of primes and things like that to help us with some cancellation and simplify that we're going to do related to multiplication and division. Another thing that's going to be important is finding the least common multiple. Or sometimes referred to as the LCM of a number. And so basically the LCM, the least common multiple of two numbers, is the number that there's the smallest number that those original two numbers that were given will divide into evenly. And so I'll go into more details about how to find that as well. All right, so let's start off with prime factorization. And so again, the idea with prime factorization is what we're trying to do is we're trying to figure out exactly how many prime numbers go into it, or powers of primes that actually go into it, and write it in that way so that again later on we can actually use this as a method to simplify fractions, multiplications, stuff like that. So for example, if we had the number 124 and I said write that in its prime factorization, you've probably done this before, but you may have actually thought of it as what's called a tree diagram. And so the idea is you kind of break it down into a bunch of tree branches by dividing, ideally, primes into it. So like for example, since this number is even, 124, then I know for certain that 2 would have to go into that. And 2, of course, is a good prime number. So when we divide 2 into 124, we're going to get 62. And we got to keep going in this manner. So again, 62 is even. So let's divide that by 2, another prime number. So 2 goes into 62, 3, 1. And it turns out 31 is actually a prime number. It can't be divided any further. So that's actually as far as that can go. So we've got to make 124. It's the same thing as saying 2 times 2 times 31. Or to write it with exponents, 2 squared times 31. And that's our prime factorization. That's our goal. So how would we actually, use a prime factorization in a problem? So what we may get is something of the form that says simplify the following fraction, 10 divided by 42, for example. So the goal is, and I think I may have talked about this a little bit in the last video as well, what we have to do is kind of simplify, break the top apart, break the bottom apart, and see what kind of factors they have in common. So in this case, 10 in its prime factorization is just going to be 2 times 5, and 42 in its prime factorization, so I know 2 goes into 42 because it's again even. So that gives us 21. At 21, I can break into 3 and 7. And all of these guys are prime. 2, 3, and 7 are all prime. So 42 could also be written as 2 times 3 times 7. So I can put those on the bottom. And by breaking them down into their primes, it guarantees us that we don't accidentally not cancel something out, because we're staring at every possible number that could go into these guys So with that in mind, we can see that the only things that are in common are just the 2's. So when we cancel the 2's out, whatever's left over will be our simplified fraction form. So on the top we've got 5, and on the bottom we've got 21. So 5 over 21 is as far as we can go with this guy. All right, is that okay? All right, very good. So now let's move on to talking about the least common multiple real quick. So again, the idea behind the least common multiple is sort of the opposite of the greatest common divisor. You may be familiar with the greatest common divisor. With the greatest common divisor, our goal is we want to find the smallest number, that divides into each of our other numbers, into each number separately. So this is kind of the opposite. We're trying to find the number that our original numbers divide into. So let me kind of show you what I mean instead. So let's find the LCM of 14, 98, and 28. And you can do this with as many numbers as possible. You can do it with 2 or 3 or 4, but typically it's 2 or 3 is the idea. So the first step for the LCM is we want to break each of these numbers into their prime factorization. So 14, in its prime factorization, is just 2 times 7. They're perfectly good prime numbers. 28 is actually 4 times 7, but 4 we want to think of as 2 squared. And then 98 breaks down, so let's do it off to the side here if you don't know what it is. So again, since 98's even, we know 2 goes into it, leaving us a 49. 49, of course, is 7 times 7, or 7 squared. So everything in sight's a prime number. So we know 98 is 2 times 7 squared. So the idea behind the least common multiple is we want whatever number we choose, whatever the least common multiple is, 14 has to divide it, 98 has to divide it, and 28 has to divide that number. So the way to ensure that 14, 28, 98 all divide this big number is what we want to do is include every prime factor in our answer, and we want to use the highest exponent of that prime factor. So in this case, if we notice, every one of them has a 2. So a 2 squared, and a 2. So we want to take the one that has the biggest exponent. So we want to grab that 2 squared. And then, now there's no 3's, no 5's. The next thing we actually come up on is 7's. And so all 3 of our numbers actually have a 7 in them. So again, we want to choose the 7 that has the biggest exponent. So in this case, 7 squared. So our number, our least common multiple in this case, is going to be the same thing as 4 times 49, or 196. And if you check, 14 divides into 196 evenly, 98 divides into 196 evenly, and 28 also divides into 196 evenly. So our number that we found is divisible by, there's 3 numbers that we started with, and that's our goal. That's what we're looking for. We're trying to actually calculate the least common multiple. All right. Well, that's enough for the background information. So now what we want to do is actually get into the 1.4, 1.5, which is talking about multiplication and division. So multiplication and division is, in my opinion, a little bit easier, I think, than probably adding and subtracting real numbers, because we have nice rules that apply every single time when it comes to multiplying and dividing. And you may have heard these rules or remember them, but the idea is if I multiply 2 positive numbers together, my end answer is going to be a positive. Same thing with dividing. If I divide 2 positives, my answer is positive. So a positive times a positive is always equal to a positive. But if I multiply a positive times a negative, that gives me a negative answer. Or if I multiply a negative times a positive, That also gives me a negative. And again, these are all true for division too. If I do positive divided by a negative, I get a negative. Negative divided by a positive is a negative. And then finally, a negative times a negative, or divided, is a positive. So the hardest part, I think, about addition and subtraction was trying to figure out, well, what sign do I end up with and things like that. And as long as we remember these 4 rules, the sign shouldn't be any issue whatsoever. In that case, all we're trying to do is actually just keep track of, what the multiplication is, and, you can use your calculator, of course, to help you with things like that. So, for example, if I had a problem like 8 times negative 7, then what I want to do is I just want to multiply the number like normal. So 8 times 7 is, of course, 56. And then to determine the sign, since I'm doing a positive times a negative, I know my answer should be negative in that case. So I end up with negative 56. And these rules apply even if you have a bunch of numbers multiplied together. So say, for example, we had something like negative 4 times negative 3 times 1 times negative 2 times positive 2, say. Bunch of numbers. And the goal is I want to multiply all these guys together, but I also have to keep track of the signs. So for me, the way I usually do it, I think multiplication works best if you think of things in terms of pairs. So instead of just trying to multiply them all together, what I would do is sort of look at, kind of starting left to right, just multiplying the first 2 numbers together, then taking that answer, multiplying it by the next number, take that answer, multiply it by the next number, and sort of build it that way rather than trying to do it all at once. Again, being mindful of the signs as we're going along. So in the first case, negative 4 times negative 3, so 2 negatives makes a positive, so that's going to give us a positive 12. And then rewrite everything. So times 1 times negative 2 times 2. And now repeat with the first 2 numbers on the left again. So 12 times 1, they're both positive, so my answer is going to be positive, is just 12. Rewrite the negative 2 and the 2. Again, keep going, work on the left. So 12 times negative 2, so since 1's positive, 1's negative, my answer is going to be negative. Gives me negative 24 times 2. Finally, I only have 2 numbers left. 1's positive, 1's negative, so my answer should be negative, and this gives me a negative 48. And that's my final answer for that guy. So again, when you're multiplying multiple numbers, again, think about them just in terms of pairs. Again, keeping track of the signs as you're going along to make sure that we don't make a mistake in that process. All right, is that okay? All right, let's keep going here. So what if we had something that looked like this? What if I had a fraction that I wanted to multiply together? How do I multiply a fraction? Well, the thing to remember about with multiplication is you have to worry about common denominators or anything like that, which again was one of the problems when we were adding and subtracting. We don't actually care about the denominator. All we want to do is actually just kind of multiply straight across the top, straight across the bottom. Again, we'll want to actually think about like the prime factorization of this guy before, because if we can simplify it, we will want to do that at some point in time. So in this case, I'm just going to kind of write it out. So I've got a negative in there, so my answer is going to be negative. But on the top, I've got, of course, 2 times 3, which is already its prime factorization. And on the bottom, I've got 5 times 7, which is, again, it's already in its prime factorization form. Since I have no common factors or primes, there's nothing to actually simplify, so I can go ahead and actually multiply these guys together and get that my final answer is negative 6 over 35. All right. Is that okay? All right. Now, the only kind of difference when it comes to division is, and now I'm going to go back to something else in a second, the only really exciting one for division is when it comes to fractions, honestly. So let's say, for example, we had a number like 6 over 5 divided by negative 3 over 4. So in this case, when it comes to division, we actually do not like to divide fractions. It just doesn't really work all that well. So instead, what we actually want to do is turn our division problem into a multiplication problem. And so the way we do this is we actually have to take the reciprocal of the last number I spelled right the first time, of the negative 3 over 4, and that will actually change our problem into a multiplication. Now all we need by reciprocal is to flip-flop the top and the bottom. So the reciprocal just means to flip the top and the bottom. So for example, the reciprocal of negative 3 over 4 is just going to be negative 4 over 3. So again, you just flip the fraction upside down. The numerator becomes the denominator becomes the numerator. So that's what we want to do for this problem from above. So the first number stays exactly the same, but now when we do this reciprocal, it's going to change to a multiplication. So 6/5 times negative 4 over 3. And then now, once we do that, it's exactly like a multiplication problem. We want to multiply across the top, multiply across the bottom, and then just be mindful if something simplifies by doing like a prime factorization on it. Again, one's positive, one's negative, so when we multiply, our overall answer is going to be negative. So what we're looking at is 4 times 6 divided by 3 times 5. And so if I put this in its prime factorization, 4, of course, is 2 times 2, and 6 is, of course, 2 times 3. So we actually have 3 copies of 2, so 2 raised to the third, times 1, 3. And the bottom, lo and behold, is already in its prime factorization form, 3 times 5. So in this case, don't forget your negative. Since we have a 3 in the top and a 3 in the bottom, they'll actually cancel out. Again, since we're looking at all the prime numbers, we know there's nothing else to cancel, so we can simplify the top down to negative 8 all over 5. And that's our final answer for that guy. So again, division of like whole numbers should be okay. That should be pretty straightforward. Again, one way to think about it is just a fraction, but these fraction ones are the ones that are a little tricky. So with a fraction, change it into a multiplication, turn your last fraction and take its reciprocal, multiply straight across, and then simplify anything that you can. All right. So one last thing is actually, what if we combine multiple operations together? So what if we have not just multiplication, or not just a division, or not just a addition, or not just a subtraction? What if we have a little bit of all that stuff going on? And in that case, we want to do what's called the order of operations to actually simplify this problem. So some of you may have heard this actually as PEMDAS, which stands for parentheses, exponents, multiplication, division, addition, and subtraction. All right. Now, one thing I want to emphasize here, because some people mess this up, is just because they write them as PEMDAS, that doesn't necessarily mean we always do multiplication and division, multiplication before division, for example. So when I actually think of these guys, multiplication and division are technically on the same scale. Same thing with addition and subtraction. They're actually on the same scale. So you can do them interchangeably. What actually determines which one you do first is which one occurs when we work left to right. So a division can be done before multiplication if, when we start on the left and work the problem to the right, that division came first. Same thing with addition and subtraction. They're interchangeable. You can do a subtraction before an addition, but what matters is which one comes first. And we work left to right. Which one occurs first? Sorry. Got the first. So obviously parentheses is where we would start, but these other two on the bottom can trip people up. And with parentheses, sometimes we'll see later on that we actually may have multiple parentheses. So you always want to start with the inside parenthesis and work your way out. And exponents are usually fairly straightforward, so that's not too bad. All right, so let me do a couple examples of these, and then I'll let you guys practice on your own. And again, feel free to let me know if you have any questions or anything like that on the homework or the reading. So this one is surprisingly tricky, and a lot of people will mess it up just because of that whole left to right thing. So in this case, there's only two operations going on completely. I've got a division and I've got a multiplication. But remember, according to order of operations, we don't do multiplication before division. We do whatever comes first when we work left to right. So as we start with the 18 and go over, we see that the first operation that we encounter is this division, which means we want to do that first. So 18 divided by 9 is 2, because 9 goes into 18 two times. Then bring your multiplication down, and now we only have one operation left, and 2 times 3 is, of course, 6. And so that's actually as far as we can go. But again, be careful of that one, because I see a lot of people actually get tripped up on ones that are exactly like that. You know, it only has 2 operations, but we kind of, like, I think we've been told over the years that because that M comes before the D, we should always do it first, and that's not the case. You always do whatever comes first as you work left to right when you're in that same scale, is the idea. All right, so let me do another one here. So let's say I have negative 7 plus 4 times negative 2 minus 9. All right, so this is a 3 operation one. I've got a plus, a multiplication, and then a subtraction there. So again, you know, according to my order of operations, technically this is a parentheses, but it's actually acting as a multiplication, so we want to treat it as a multiplication. So there's no parentheses, there's no exponents, so the next thing on our list would be the multiplication. So we actually want to go in here to the middle, perform our multiplication. So we're multiplying a positive times a negative, so remember our answer should be a negative. So 4 times negative 2 gives us a negative 8. So bringing that down, we get negative 7 minus 8 minus 9. So now what we've got is we want to combine this negative 7 and this minus 8. But remember, anytime we want to do a subtraction, this goes back to 1.3, it's better off to think of it as an addition. So let's rewrite this guy as an addition problem. So negative 7 minus 8 is the same thing as negative 7 plus negative 8. And then just bring our minus 9 along for the moment. So what we're adding is 2 negative numbers. So remember, when we add 2 negative numbers, that just gives us a smaller negative number. So in this case, negative 7 plus negative 8 gives us a negative 15. Bring the minus 9 down. Again, we don't like to subtract these real numbers. We'd rather add them. So let's go ahead and change this again to an addition. So as an addition, this is going to be negative 15 plus negative 9. So again, we're adding 2 negative numbers, which is going to give us an even smaller negative number. So just add them like normal and attach the negative sign. So negative 15 plus negative 9 will give us a negative 24. And that's as far as we can go with that guy. All right. Well, again, hopefully this will help. If you have any questions, definitely let me know. Shoot me an email. If you're having trouble with any particular homework problems, feel free to write down what you've been doing. I can make up a quick little video and post it to you to kind of get you back on track. Otherwise, good luck, keep working, be patient. We will get to meet hopefully. But otherwise, please keep working on the material. The goal is by this weekend, I'd like to have everybody, trying to work, all the problems up through 1.5. I know you may struggle with some of them, but, don't give up, keep working, and definitely ask questions. So I'll leave it at that. And like I said, good luck, and let me know how you're doing.